Okay, hi. In this video, I'll be discussing three questions from analog circuits, and these three questions have appeared in the recently conducted GATE examination for ECE stream. So on the screen, you can look at the first question. So in this question, we have an op-amp for which the input is applied at the plus input terminal, and we are asked to find the output current I0, and the value of input is 2 volts. Well, the first thing you can notice is that the output of the op-amp through this 1 kilo ohm is connected to the minus input terminal, which means this particular op-amp is in negative feedback. Whenever an ideal op-amp is in negative feedback, you know virtual short will be valid, which is V plus equal to V minus. So let me also write down the value of input on the circuit diagram, 2 volts. So the voltage at this point is 2 volts. Well, the other thing you can notice is that this circuit is nothing but the non-inverting amplifier, wherein this is R2, this is R1. So here both R2 and R1 are equal to 1 kilo ohm. So the gain of this non-inverting amplifier will be 1 plus R2 by R1, which is 2. So the output voltage of the op-amp, that is the voltage at this point, will be 2 times 2, which is 4 volts. And also, you know, for an ideal op-amp, the input current is 0. Since this current is 0, R2 and R1 both are going to be in series between 4 volts and ground, that is 0 potential. So the current in this branch has to be 4 minus 0 by 2 kilo ohms, which is 2 milliamps. And the current in this branch will be 4 minus 0 by 1k, which is 4 milliamps. Now at this node, I0 is entering, 2 milliamps and 4 milliamps both are leaving. So if you write KCL at this node, I0 turns out to be 2 plus 4, which is 6 milliamps. So the answer to this question is 6 milliamps. Well, this is an extremely easy question. Just by looking at the circuit, we can say the value of I0 is 6 milliamps. Okay. We'll move on to the next question. So once again, we have an op-amp circuit, but this time the output of the op-amp through this 1 kilo ohm resistor is connected to the plus input terminal, which means this op-amp, it is in positive feedback. Well, you know, any op-amp which is in positive feedback will behave like a Schmitt trigger. And for any Schmitt trigger, you know, the first thing we always do is to plot V0 versus Vi. So for this Schmitt trigger also, if you try to plot V0 versus Vi, you will get the following plot. So this is the resulting plot between V0 and Vi for this Schmitt trigger. So you can observe that the two tree points are plus 5 and minus 5. And also the loop, it is in, you know, counterclockwise and anti-clockwise direction. Now for the given input, let's find out what the resulting output is going to be. So what is the given input? 1 volt sine omega t, which is a sine wave that varies continuously between 1 volt and minus 1 volt. So on the input axis, let me label 1 volt and minus 1 volt. And the input in this case, like I just said, will vary between 1 and minus 1. So clearly the input is always varying within the loop. It never goes outside of the loop. So for any Schmitt trigger, the output changes from Vsat to minus Vsat or from minus Vsat to plus Vsat only when the input goes from inside of the loop to the outside of the loop, or when the input goes from one side of the loop to the other side of the loop. But in this particular case, the input always is varying within the loop, in which case the output does not really change between Vsat and minus Vsat. So the output will be constant of either plus 5 or minus 5 volts, which is nothing but option A. So the answer to this question is that the output is a constant of either plus 5 or minus 5. Let's move on to the next question. So here we have a circuit that has two capacitors C1 and C2, and also two diodes D1 and D2. Well, the simple observation one can make is that this circuit can be thought of as being a combination of two blocks. The first block being C1 and D1, which together will form a positive clamper. And the second block comprises of D2 and C2, which will form a positive peak detector. So this circuit is a combination of a positive clamper and a positive peak detector. Well, all of you know this combination will result in, and you know, for a voltage doubler, the output is twice the peak value of the input, that is V0 equal to 2 Vp. So in this question, 230 volts is nothing but the RMS value of the sinusoidal input. So the peak value will be 230 times root 2. So the output will be 2 times 230 times root 2, which is 650.44 volts. So that is the answer to this question. Well, all the three questions are extremely simple, and everyone should be able to answer without much effort. I will see you in the next video. Thanks.